So we're now moving into Chapter 6, which we are going to talk about different types of equations. So in Section 6-2, we're talking about formulas. What you will learn in this section is 1. How to evaluate a formula. 2. How to solve for a variable in a formula. A formula is an equation that typically has a real-life application. To evaluate a formula, substitute the given values for the respective variables and then evaluate using the order of operations. So our first example is simple interest. The simple interest formula is interest is equal to principal times rate and time. And so we have the following formula. I is equal to PRT. And it is used to find the interest you must pay on a simple interest loan when you borrow principal P at an interest rate R in decimal form for time T. We assume that the rate is annual. So our first example is Chris Campbell borrows $5,000 at a simple interest rate of 6% for 3 years. Our first question is going to be, how much will Chris Campbell pay in interest at the rate of 6% for 3 years? And B, what is the total amount he will repay the bank at the end of 3 years? So in part A, we ask how much will Chris Campbell pay in interest at the end of 3 years? Our solution is follows. Obviously, when we read the problem, we found that the principal is equal to $5,000. The rate of interest annualized is at 6.5%, and the time period in which the interest is accumulated is 3 years. So we have the formula I is equal to PRT, and we plug in the various values for the variable to evaluate. We plug in 5,000 for P. We plug in 0.065. Notice we've changed percentage to a decimal form for R. And finally, we have 3 years for time T. When we do the multiplication, we get 975. So our interest that we're actually paying is $975 in interest over the 3-year period of time. So now we ask the question, what is the total amount he will repay the bank at the end of 3 years? Well, the total he must pay at the end of 3 years is the principal originally that he borrowed from, $5,000, plus the $975 of interest. And then for the total, he has ending up to be $5,975. So if we were to express this in a formula, the final amount A that he has to pay is equal to the principal plus the interest involved. So we're now going to look at a geometric formula. We've seen some of them in the past for rectangles and for perimeters, for area and perimeters, and now we're going to look at volume. The formula for the volume of a rectangular box is the volume is equal to the length times the width times the height. It's represented in the following fashion, which we have as V is equal to L times W times H. And we use the formula to find the volume, obviously, of a rectangular box. So if we use this formula to find the width of a rectangular box of ice cream, if the length is 7 inches long, the height is 3.5 inches, and the volume is 122.5 inches cube, rather big box of ice cream, I might say. The question is how do we find W? Well, here's our formula, and we're going to plug in the values for the different variables. So we plug in 122.5 for V, we plug in 7 for L, and we plug in for the height 3.5. Now we have to solve, in this particular case, we have to solve for W. And so what we do is we multiply the 3.5 times the 7, and we get 24.5 times W. And now to isolate, we have to isolate W on one side of the equation to solve for it. And when we do that, we divide both sides of the equation by 24.5. That is our principle of equality. And we ultimately get our answer of W is equal to 5, right? So our answer is the width of the ice cream box is 5 inches. So our mathematical models, when we represent real phenomena, such as finding simple interest, mathematically we say we have created a mathematical model, or simply a model to represent the situation. A model may be a single formula, an equation, or a system of many equations. One example is a linear model, which we will see in this chapter. For example, for a linear model, we have y variable is equal to mx plus b. Y is considered the dependent variable. X is considered the independent variable. M is the slope of the line, and B is equal to the y-intercept. This linear model will be used to solve linear equations. Many formulas contain Greek letters, such as mu, sigma, capital sigma, delta, capital delta, epsilon, pi, theta, and lambda. These are all mathematical ideas sometimes that are used in formulas and so forth, and to represent numbers. One such idea is a formula used in the study of statistics to find the standard score, or z-score. The z-score is used to measure the distance a value of the sample mean is from the actual population mean. And here we have z is equal to x bar, which is the mean value, minus mu, divided by sigma over the square root of n. In statistics, sigma is what we call the standard deviation, and n is the sample size that is used. We find the value of z, so it says find the value of z when x bar is 120, mu is 100, sigma is 16, and n is 4. So the solution is we plug in 120 for x bar, we plug in for mu 100, we plug in 16 for sigma, and n, of course, goes in as n, 4 for the square root of n. When we plug in the numbers, we see that we have 120 minus 100. divided by the square root, or divided by 16 divided by the square root of 4. So we have 20 divided by 16 over 2, which is 20 over 8, and we have a z-score of 2.5. Our meaning in this particular case is that the sample mean is approximately 2.5 standard deviations from the population mean. Rather unusual. Some formulas contain subscripts. Subscripts are numbers or letters placed below and to the right of the variable. For example, if we have two different amounts that are used in a problem, they may be symbolized as A or A naught. The A sub 0 refers to A naught, or A1 reads A sub 1, and A2 reads A sub 2. Typically, when we're talking about a sequence like we've already discussed, we have AN is equal to A1 plus N minus 1 times D. Remember, that was our formula to find an arithmetic sequence. We used a subscript in this case as the first position in the sequence, and AN to be the last sequence, the last number in the sequence. So suppose you are given a formula or an equation expressed in terms of one variable and then asked to express it in terms of a different variable. To do so, we treat each of the variables except the one that you are solving for as if it were a constant. Then we solve the variable desired. So in other words, we put in the information into the variables in the equation that we have, and the one that we don't have, we isolate it on one side of the equation. So in this example, we want to solve the equation 2x plus 5y minus 10 equals 0, and we want to solve it for y. So the first step is, here's our original equation, and now we are going to subtract 10 from both sides of the, or add 10 to both sides of the equation. What that does is it moves 10 from the right-hand side, the left-hand side of the equation, to the right-hand side. Now we have the equation 2x plus 5y is equal to 10. Now, since we're solving for y, we're going to move the 2x to the right side of the equation. To do that, we subtract 2x from both sides of the equation. Now we'll go to the next page. So because we've taken a negative 2 from both sides of the equation, we now have 5y is equal to a negative 2x plus 10. Well, we still want to isolate y on one side of the equation. So we divide both sides of the equation by 5 using the principle of equality, and we get a minus 2x plus 10 divided by 5. So our equation now looks like this, and we have temporarily solved the problem. However, we want to rewrite this equation in a form that we will recognize in the future. So we go to the next page. So the equation is solved for y, obviously, but it isn't in the form that we would like it to be. The solution can also be expressed in the form y is equal to a negative 2 over 5x plus 2. This is a form which we will call eventually a linear form, where negative 2/5 is the slope m, and 2 is equal to the y-intercept. and this form is convenient for graphing linear equations. So now we have an important formula that's used in statistics, which again is the z-score, but this z-score is used to determine a particular value in the population from its mean. So we solve this equation for x in this case. When we do that, we multiply both sides of the equation by sigma, which is the standard deviation of the population, and we get z sigma is equal to x minus mu, and then we add mu to both sides of the equation, and we're solving for x. And so now we get z sigma plus mu is equal to x, or x is equal to z sigma plus mu. So in a standardized population, we always can find the value for x given its standard deviation from the mean times the standard deviation plus the mean of the population. This you will learn if you go on to the statistics course 1330 class. You'll learn more about this particular formula. Well, this concludes our formulas in chapter 6.2. Our next chapter is going to discuss linear applications of one variable.